suvat formulae, part 1. The suvat formulae give you a relationship between displacement s, initial velocity u, final velocity v, acceleration a, and time t in 5 convenient formulae. We must have constant acceleration, so the a is a constant in all of these formulae. If the acceleration is not constant, then we have to use calculus for problem solving, for instance differentiation and integration. The basic units for distance and displacement are the same. The SI units are meters. In this example, if somebody travels from A to B along this path, the distance travelled is 58 meters, and that's a scalar quantity. Distance does not take the direction into account. We're just looking at the total distance travelled from A to B, the length of this curved path. The displacement is the difference between where you start and where you end. So if you join the start and end with a straight line, it's the length of this path here. And the displacement is 42 meters, but displacement is a vector. It has a direction. So we could give a bearing for the direction from A to B. If a person walks from A to B along a straight line, then so long as they keep walking in one direction, the distance and displacement are exactly the same. If, however, the person is walking from A to B and then stops at some point and then starts walking back towards A, now the distance and displacement are different. The distance travelled now would be from here to where the person stopped, and then the person changed direction and came back to this point. So it would be the length of this line and this line. But the displacement would be from here to here, the length of this line. Starting from A again, we can say that the displacement S is 0. If I take the right hand side as positive, so any motion to the right from this point will be positive. So this person might walk from A to B, and A to B might be 100 meters. So the displacement now is 100 meters. If the person walks back towards A and stops roughly here, then the displacement here might be 25 meters. And then if the person walks back to A, the displacement now is 0 again, but walking towards the left in this direction, let's say to a point C, now the displacement will be negative. So the displacement here might be minus 30 meters. So distance and displacement are the same only when there is motion in a straight line and only in one direction. Speed and velocity both have the same SI units, meters per second, but speed is a scalar. It doesn't take the direction of motion into account, but velocity does. Velocity is the rate of change of the displacement, and speed is the rate of change of distance. If motion is along a straight line in one direction, then speed and velocity are the same. If, however, an object is changing direction, for instance, we have two cars. They are both doing 25 meters per second, that's their speed, but they are going in opposite directions. Now the speed doesn't take that into consideration, but the velocity is a vector, it does. So we have a positive velocity here and a negative velocity here because the direction is opposite to this one. Acceleration is also a vector, the rate of change of velocity with time, units meters per second squared. So just like any other vector, for instance displacement or velocity, acceleration is a change in velocity. That could be a change in speed or direction or both. In this example, the blue car is speeding up, so it's accelerating. If I take the right hand side as positive, then the velocity here is positive, and because it's speeding up, the acceleration is also positive. The yellow car is also moving towards the right, so its velocity is positive, but this car is slowing down. It's decelerating. So if it's decelerating at 3 meters per second squared, we could say that it's accelerating at -3 meters per second squared. Now go on to the suvat formulae part 2 video.